Hello, friends. Today we are discussing a topic on calculation and chemistry. And under calculation and chemistry, we are discussing atomic mass. That's what we are discussing. We are discussing atomic mass and molecular mass. Now, before we go fully into today's lesson, I would love us to see a couple of things. Now, that's what I want us to see. Now, every substance you see around you, be it the food you eat, the cream you use and the perfume you wear and so on and so forth. Every substance you see around you, which we refer to as matter. When we talk about matter, what is matter? Matter is anything that has weight or mass and occupies space, or we call it volume. Now we talk about weight and mass. What's the major difference? Now a mass is simply the elementary particles a body contains, while weight is simply the mass of a body in comparison with gravity. So when we talk about matter, everything around you, the food you eat, the clothes you wear, even everything, even you as a human being, you're a matter. So a matter could be either a compound or a mixture. For example, we have H2O2, this hydrogen peroxide. This is a bleaching agent. It's an oxidizing agent also. So, such as H2O2, we also have water, H2O, and so on and so forth. All those things are matter around us. So when we talk about matter could be even the clothes you wear is a matter. So a matter, which is everything around you, the air you breathe, the water you take, and so on. So a matter could be a compound or a mixture. So when we talk about a compound, what's a compound? A compound is simply a kind of matter which involves the bringing together of various elements using a chemical means. For example, an acid is a compound. H2O2, hydrogen peroxide is also a compound. Water, H2O, is a compound also. And when you talk about a mixture is simply, a kind of matter that involves the bringing together of various elements using a physical means. Now, most compounds experience irreversible change, while mixture experience irreversible change. So they are different. That's a topic for another day. For compounds, the change is irreversible. New substances are formed, while this one, is the change is reversible, and so on and so forth. So don't forget we are discussing atomic mass and molecular mass. So a matter, which is either a compound or a mixture, when you check a matter, that is when you check a compound or a mixture, what you're going to find, you're going to find elements or molecules. Every compound is made up of elements or molecules. For example, hydrogen peroxide is made up of hydrogen element and also oxygen. These are the two major elements that we have in hydrogen peroxide. Even in water, H2O, you have hydrogen and oxygen, which are the two major elements. Now, as you can see, we could also call them molecules, because this is not just one atom of hydrogen. This is two atoms of hydrogen, which is hydrogen molecule and oxygen molecule. So when you check every substance like water, alcohol, food, and so on, these substances that we also call matter are either compounds or mixtures. Now, when you check them, you find out that they are made up of elements and molecules. And also, when you check your elements and molecules, don't forget, when we talk about element, according to chemists, an element is that very simple part of a substance, or I can call it the simplest part of a chemical substance in a chemical reaction. So elements could come as individuals, as units, but molecules always come in a combined state. If atoms of different elements are not combined together, they won't be a molecule. So when you check a molecule or an element, we end up having what we call atoms. What's an atom? An atom is simply the very small part, or probably the least part of a given substance that still retains its chemical identity as a part of an element. That's what an atom is. So when you talk about an atom is simply that very substance that come together. It could be, according to John Dalton, when you check every element has its own identical set of atoms. Hydrogen has its own hydrogen atoms, calcium has its own calcium atoms, and so on and so forth. So elements and atoms are made up of elements and molecules, are made up of atoms. While when you break down atoms, you have what we call the proton, the neutron, and the electron and the positron. Positron is a positive electron. That's a topic for another day. So, and when you now check the proton, the neutron, and the electron, we have what we call the charges. The charges could be positive charge, negative charge, or the neutral charge for the neutron. So, Now, this just the breakdown, or I can call it the analysis of every substance you see around you, be it alcohol, food, and so on and so forth. All the substances, they are matter. So the matter could be a compound or a mixture. So by the time you break them down, every compound or mixture has elements or molecules. Every element or molecules has atoms. Every atoms has proton, neutron, electron, and probably positron. And all the stuffs, yeah, they carry charges. So as you can see, this is a boron atom. A boron atom has, let me just use this to analyze. When we talk about an atom, for example, in an atom, we have what we call the nucleus. The nucleus is the central part of an atom. Now, every nucleus is made up of what we call the proton and the neutron. Now we call that the nucleons. So a proton is positively charged, while a neutron does not have a charge at all. So around the nucleus, we have what we call the shells. Look at the shells here. This is an atom we're talking about. This is a boron atom. So here we have, for boron, we have the first shell has 2 atoms, and then the second shell has about 3 altogether, 2 for the S shell also, and one which is for the last P. So every atom has a nucleus and also has the shells around it. Now, for the shells, they carry electrons. Electrons are negatively charged, and that's why there's always a strong attraction between the proton, which is positively charged, and the electron, which is negatively charged. The neutron does not have any charge; it's just neutral. So we're going to be looking at mainly the atoms and the molecules. That's what you're going to be looking at. So you're going to be looking at the mass or the weight of an atom or molecule. Don't forget, mass and weight, they look very much alike. Mass is simply elementary particles, all the particles a body contains, while weight is simply the mass of a given body, in comparison, or I can say the mass of a given body under the effect of gravity. So weight is simply mass times gravity. So when we talk about the mass of a given substance, what does the mass of a given substance mean? Mass is simply, atomic mass, I beg your pardon, is simply the mass of an atom gotten from the summation of the unit of proton and neutron. So when we talk about the mass of an atom, it's simply gotten when we combine proton and neutron together. So the mass of an atom cannot be gotten by considering electrons. So for us to get the mass of an atom, we mainly consider this nucleus. It's the nucleus, that is the proton and the neutron, that we put together to give us the heaviness or the mass of a given atom. So don't forget, now let's see the reason why we mainly use the proton and the neutron to get the mass of an atom. Now this is it here. Every proton has 1 atomic mass unit, just 1 atomic mass unit. Neutron also has approximately 1 atomic mass unit, but electron has a 0.0005446, and approximately, let me just say 0.0005447 atomic mass unit, which is too small. And that's why each time we want to get the mass of an atom, we don't consider an electron, because the atomic mass unit of an electron is very negligible. So most times it's always 1/1836, of 1 atomic mass of a proton. So whenever I want to get the mass of an atom, it's always proton plus neutron. So let's look at this. Let's look at a couple of this element. So if you look at this element, hydrogen as an element has just 1 atomic mass, that is 1 proton, but doesn't have a neutron. So hydrogen is 1 atomic mass unit for proton and 0 atomic mass unit for neutron. So when we talk about hydrogen is called protos. That is the first ever element that we have. So it has just 1 proton and no neutron. So hydrogen has 1 atomic mass unit. Now let's look at carbon. This is a carbon-12 atom. Now carbon has 6 proton, that is 6 atomic mass unit for proton, and 6 neutron. Let me say that. So altogether for a reference point carbon, we have 12 atomic mass units. Now for chlorine, we have 17 protons and 18.5 neutron. Altogether, we have 35.5 atomic mass unit for chlorine. Don't forget, we're talking about the heaviness, the mass of an atom. So don't forget this proton and neutron that you bring together to get the mass of an atom. Now, when you look at this, now according to Henry Moseley, every element is arranged on the periodic table using the proton number. Now, this proton number is also known as atomic number. So we can say hydrogen has atomic number of 1, helium 2, lithium 3, beryllium 4, boron 5, and so on and so forth. So carbon also has atomic number of 6. But each time we want to get the mass of these atoms, we have to combine the atomic mass unit for proton and atomic mass unit for the neutron. So most times they are often almost the same, but not entirely the same. Sometimes we have varying numbers of neutron number that brings about what we call isotopes. We're going to talk about that in the next exposition. So that's just that for atomic mass, the combination of proton and neutron. So the next thing we're going to be looking at right now is what we'll call molecular mass. So when we talk about molecular mass is the mass of a molecule. Now when we talk about molecule, don't forget, as I said up there, molecule is simply the combination of atoms. When atoms combine together, we end up having, molecules, or probably we could say that we have an element of we have atoms of an element. But when we talk about molecule is simply atoms of an element being put together. Now, for molecules, they can't exist alone. Atoms of an element cannot exist alone, unlike just just an element. But for molecules, we have atoms of an element being put together in a combined state. So what's the molecular mass? Molecular mass is the mass of a molecule, that is atoms being put together. Now it could be identical, which is we have examples like H2. Now when you look at H2, this is a molecule of hydrogen. H2 is we have two molecules, two atoms of hydrogen, I beg your pardon. So that's one atom of hydrogen plus another one atom of hydrogen, which is two atoms of hydrogen. That gives us a molecule. Now this O3 ozone, we have three atoms of oxygen together. Now all these are molecules. Now what kind of molecules are these? They are identical molecules. Now they could also be non-identical, which is HCl, for example. I could call this a molecule of hydrogen chloride. Let me use the word HCl, a molecule of HCl. We could have H2O also, H2O, that's a molecule of water. You understand? So we have two atoms of hydrogen and one atom of oxygen, for example. So when we talk about molecular mass, it's simply the combination of atomic masses. You understand? So different masses of an atom being put together to get what we call the molecular mass. So the last thing we're going to be looking at today, we're not going to be dealing with calculations at all. We said it already. We're going to be looking at what we'll call relative atomic mass. Now, don't forget, relative atomic mass is the same thing as atomic mass up there, and also relative molecular mass, same thing as molecular mass. So when we talk about relative, the difference there is just a relative there. So when we talk about relative atomic mass, we're talking about the mass of an atom of an element in comparison with carbon-12 atom. Now, when you look up there, there's a special there's an atom of an element, and the element we're talking about there is carbon. Now, carbon is a special kind of element that chemists often make reference to. So we talk about carbon. The carbon we're talking about here is carbon-12, not carbon-13, and we're talking about a special kind of carbon, which is carbon-12. Now, if you look at carbon-12, we have equity between the amount of proton and the amount of neutron. So here we have 6 proton and 6 neutron. So it's more or less like perfection. So we end up having 12 atomic mass unit, unlike chlorine, which is 17 and 18.5 on this other hand, 35.5 atomic mass unit. So but for carbon-12, we have 6 proton and 6 neutron. Don't forget, proton is called atomic number. Elements are arranged on the periodic table based on their atomic number. Carbon is number 6 on the table, so we have 6 proton. So now when we talk about relative atomic mass, you're talking about the mass of a given atom in relationship, with carbon-12 atom. So that's what it is. And also it is simply how much heavier the atom of an element is than 1/12. That's 1/12 of carbon-12 atom. So when you talk about relative atomic mass, it's simply the mass of an atom of a given element in comparison with carbon-12 atom. So look at it. You have a formula here. Relative atomic mass is the mass of an element divided or in comparison with 1/12. That is 1/12 of one atom of carbon-12 atom. So under relative atomic mass is still the mass of an atom of a given element, but this time around we are trying to compare it with carbon-12 atom, which is a reference point for every other kind of atoms of element. So the next thing we're going to be looking at is what we call the relative molecular mass, or the relative formula mass. Now, why do we have to call it relative formula mass? Now, don't forget that when we talk about molecules are simply stuffs in combined state. When you talk about molecules, you talk about atoms in combined state. So when we talk about relative molecular mass, more or less like, let's say, oxygen, O2, HCl, which look at this HCl, this could be hydrochloric acid, H2O water. Now all these things are more or less like, you could call them formulas. So H2O is a molecule, but that's a formula for water. So when we talk about relative molecular mass or relative formula mass, it is simply the mass of a given molecule of a substance in comparison with carbon 12 atoms. So the word relative there has to do with comparing it with carbon 12, atom. So, and also it is how much heavier a molecule or a formula unit is than 1/12 of an atom of carbon 12 atom. So yes, a formula, relative molecular mass, is the mass of a molecule of a substance or the mass of a formula unit of a given substance. It could be a compound. Now, in comparison with 1/12 of an atom of carbon 12 atom. That's what relative molecular mass is. So it's the same thing with molecular mass, but this time around, we are comparing it with the carbon 12 atom. And also, don't forget, in our previous lesson, we are told that relative molecular mass also is 2 times vapor density. 2 times vapor density. So I would love us, at this very point, to learn all this. We need all this because in our next association, we're going to be working on various calculations on relative atomic mass and relative molecular mass, or rather atomic mass, molecular mass. So at the very point in time, we're drawing the curtain of today's lesson. So if you found this lesson resourceful, please subscribe to this very channel and share this lesson with others. See you in the next lesson. Thanks.